We'll now demonstrate two-stage modeling tool we have developed. This is an architecture modeling tool that can generate prototypes of various designs from the same functional requirements. For this purpose, we divide the modeling process into two stages: the data flow modeling stage and the control flow modeling stage. In the data flow modeling stage, functional aspects of an architecture model are modeled. In the control flow modeling stage, many variations of object-oriented designs can be examined. From the architecture model, an executable Java prototype can be generated. The data flow part of the architecture model can also be specified by an architecture description language, ADL. Here, we load the model file of an analog clock application written in the ADL. After reading the file, each component and data flow are represented by an oval and a red arrow, respectively. In this clock application, the states of min and error components are updated whenever a tick event occurs. In addition, their presentations min ang and error ang are also updated. Here, we can consider min and error as model components, and min ang and error ang as view components in MVC architecture. Between two components, generally, data can be transferred in push or pull style. The data transfer method can be selected by the pull-down menu. Data transfer methods are selected in the push-pull selection step. That is the first step of the control flow modeling stage. The second step of the control flow modeling stage is the control flow delegation step. Let's switch to the control flow delegation step. In this step, each control flow is represented by a blue arrow. By comparing with the data flow graph, we can confirm that the directions of control flow and data flow are the same in push style, but those directions are the opposite in pull style. In this way, we can generate the source code of both push style and pull style MVC architecture. Next, we try to change this model to MVP architecture. So, we change this data transfer to push style and switch to the control flow delegation step. First, we insert a mediator component here. By right-clicking the control flow, selecting Insert Mediator, and entering the name, the mediator component is created and represented by a hexagon. Next, we change the structure of the control flow. Double-click this control flow. Then, the candidates of the new source are shown in green. By double-clicking a candidate, it becomes the new source. We call this operation control flow delegation. We also apply control flow delegation to this control flow. Then, we can obtain the MVP architecture. Also, we can generate the source code of this architecture.